Welcome engineers, Hassan here. Today we are talking about the performance of floating point arithmetic. We have recently covered integer and floating point arithmetic. We know how to divide integer numbers in binary, understand how floating point arithmetic simplifies our calculations, but which one is faster? Let's find out. We are going to generate an array of 1 million random values, add all of them together and time it. We are going to perform this measurement several times and average the result. Then, we are going to repeat this for each data type and each operation. There are many different benchmarking tools. I am a big fan of Java Microbenchmark Harness. It is reliable, consistent, and easy to configure. It removes a lot of traps associated with benchmarking. Let me know if you're interested in this topic. I may make a video about it. Now, let's jump into the results. Well, we are off to a good start. As we can see here, both addition and subtraction take almost 3 times longer when using floating point data types compared to integer data types. This is expected, considering how trivial both operations are for integer types. With floating point numbers, we must first bring them to the same exponent, add significance, and normalize the number. Interestingly, multiplication has exactly the same performance with both data types. Also, multiplication takes just as much time as addition and subtraction for floating point data types. This is the beauty of floating point arithmetic. Not only it unlocks a bigger range of values for us, but it also remains very efficient. We multiply exponents and significance separately, reducing the total number of operations we need to perform. As you can see, the division is the slowest of 4 operations for both data types, but the integer division is about 30% faster. Let's visualize our data with a bar chart. As we can see, performance is actually comparable and closer than one may anticipate. Integer arithmetic performs a little better overall. The division takes about 30% less time and 60% less when performing addition and subtraction. Multiplication performance is the same. Similar observations could be made for 32-bit data types. Comparing 32-bit and 64-bit integers, we see almost the same results. Most modern CPU arithmetic units usually have 64-bit registers anyway, so it doesn't matter whether you are loading 32-bit or 64-bit integers. The only difference between these two tests can be attributed to the number of fetch operations a CPU has to perform, since you can fit more 32-bit integers on one cache line. This is probably a topic for another day. Floating point numbers see noticeable improvement when using 32-bit data types during division. This may be due to the fact that coprocessor 1, responsible for floating point arithmetic, uses 32-bit registers. They are used in pairs to store 64-bit floats. Perhaps this complicates division logic. The point of this benchmark is not to decide which data type to use based on the performance. A proper data type is determined by the data we want to store. Performance bottlenecks rarely come from data type choice. However, it is useful to understand how changing data types may have far-reaching implications. This becomes even more important once we start using long arithmetics or variable length data types. Both are very common in the data processing. Today we made a benchmark to compare basic arithmetic operations using integer and floating point data types. If you're interested in a more detailed explanation, the link to my blog will be in the description. Leave your questions and comments down below. Thank you for watching.